In previous lessons, the teacher has discussed these concepts with the learners and will now start a practical lesson to verify them.
Some of the activities that they do at their homes form scientific kind of chemical reactions. So when you say that a mixture is mixing some substances, they tend to have this scientific concept divorced from what they do at their homes. Yet that's exactly one and the same thing. So the science part of it is enhancing it's enhancing their understanding of what they may be doing at their homes as well.
The teacher begins the lesson by dividing the class into groups and presenting each group with samples of various household mixtures and a worksheet. Learners are left to discuss and form their own conclusions.
No.
Yeah, we have solid.
Solid is not.
We have solid. And then water, it's...
In question 1, learners must explain if the sample is a heterogeneous or homogeneous mixture and why they say so. In the first example, the learners look at a mixture of water and powder paint.
It's a heterogeneous mixture, sir, because it is not clear firstly, and then the powder paint is suspended to the bottom of the container.
Do you agree?
Yes.
Okay.
Here, water and glycerin are mixed together. When they are mixed together, the particles of water and glycerin, they combine. They make the solution will be in one phase. Therefore, this is a homogeneous mixture.
In another example, salt is mixed with oil.
Just try to mix the two. Do they mix?
No, sir.
They don't mix. What happens?
Salt comes down, sir.
The salt starts to accumulate at the bottom of the container.
Yes, sir.
And then is it a heterogeneous or a homogeneous mixed?
Heterogeneous.
Water and oil, it is a heterogeneous because they are both separated from each other.
Now, let us take water and soil. Please take this one, shake it. Now, what do you see happen?
I see some particles are suspended, but they are dropping down to the bottom of the container.
Now, what type of a solution is this one?
Heterogeneous.
Heterogeneous, because the mixture is made up of two substances which can be seen physically by your naked eyes.
The teacher listens to the discussions, and when he is satisfied that learners are familiar with these terms, he discusses that mixtures exist in different phase combinations.
We have 3 phases of matter.
Solid, liquid, and gas.
Can a combination of these 3 form solutions? So a combination.
In the next question, learners must decide in which combination of phases their mixtures exist.
Water and glycerin. Liquid in liquid.
Chicken water, it's liquid in liquid.
Water and ice and sugar. Ice and sugar, yeah. Solid in liquid. Yeah.
The teacher moves between the groups and asks leading questions. In this example, learners refer to a mixture of iron filings and glycerine.
Solid in liquid.
Which one is the solid?
The iron filings.
Iron filings, and glycerine is the liquid.
As an extension to this activity, the teacher explains that one component is a solute and the other the solvent.
The one that is in high quantity is the solvent, and the one that is in low quantity is the solvent.
The teacher refers to the example of sugar mixed with water.
Water is the solvent and sugar is the solute.
So water will be the solvent because it is in high quantity, and sugar will be the solvent. Water is the solvent and oil is the liquid.
For question 3, learners must say if any of their mixtures represent a solution, a suspension, or a colloid.
It is a suspension because the salt particles are suspended down. They are suspended.
It is important for learners to macroscopically observe the different mixtures. This will enable them to distinguish between solutions and other types of mixtures, like suspensions and colloids. Remember that a colloid is a heterogeneous mixture where the particles, which consist of molecules or clusters of molecules, are big and remain suspended in the solution. Some examples include milk, mayonnaise, and margarine.
The reason that is useful in understanding homogeneous mixture, namely the solution, is it sets up a contrast. And you say, see, that is what I mean by heterogeneous. See, that's what I mean by homogeneous. You can see, just with your eyes, they look like different mixtures.
In the next question, learners had to say which of the ingredients would dissolve in water.
Glycerin dissolves in water. And then jig also dissolves in water. And iodine also dissolves in water.
And what type of mixture is an oil-water mixture?
Oil does not dissolve in water. It's a heterogeneous mixture, sir.
Do they form a suspension, or does one accumulate at the bottom and the other one at the top?
Yeah, one accumulates at the bottom and one at the top, sir.
So it is a type of a suspension. Yes. Thank you.
In this activity, learners are required to make a rough drawing showing the arrangement of the particles that make up a solution and a suspension.
It is very difficult because those atoms and molecules are too small to see. So you have to construct that picture, that image, in your mind on the basis of all kinds of clues. And of course, a science teacher is fairly expert at making that linkage, and through practice becomes quite at home making that connection. But for beginners, it's difficult.
Once the learners have completed their drawings, the teacher walks around and evaluates.
Now, this one will represent not a solution because if you look at the pattern, how the particles are arranged, they are arranged systematically, more of a solid-like structure. And because it is uniform, it can therefore not be equated to that model of the jig in small amounts being dissolved in the water amount. The idea now would be to arrive at one accepted drawing, but which is not that much important as to how do we arrive at that. So as they continue to draw and make mistakes, and they are being rectified, this is when their understanding is more enhanced.
In this activity, learners will discuss particle diagrams to determine what they could represent.
What does figure A represent?
Figure A is a homogeneous solution because of the solvent is greater than the solute, and we see that they are evenly spread.
C is?
A pure substance.
Sketch E, what is the answer to sketch E?
Homogeneous mixture.
Homogeneous mixture. Why homogeneous mixture?
They are in solution. It's a solution.
The teacher will go through all the drawings and discuss.
Linkage in the classroom, mediated by the teacher, is something that has to be worked at pretty consistently, a little bit each day, helping people to getting into that way of viewing things. It's not easy. You can see the pictures, but to think it and make it part of your way of thinking about matter is really a non-trivial task.
Hi everyone, now that you have watched the video, I would like us to talk about it. At the studio today we have Liz from the University of Wits, and then we have Andrew from Protech and Kanye from the Science Education Project. Let us talk about the lesson that we have just observed. The teacher was talking about solutions, and solutions is a very important topic to teach about at the FET phase. Why do you think it is important?
I think solutions form a basis for a lot of other topics. If one wants to understand about acids and bases, one needs to know about solutions. Mm-hmm. So it certainly relates to some of the current topics that are in the FET syllabus.
Mm-hmm. Mm-hmm. And then the teacher started off by actually discussing the examples, the everyday examples with learners. What do you think this was a good idea to do in introducing the topic solutions?
Yes, I think everyday examples, takes the whole thing away from the abstract and makes it really concrete and real for the learners. Mm-hmm. Because, science is not something that we do in a vacuum. So it's very important for learners to actually see how we derive some of these things and how we think about these things. That these things actually are happening all over and all around them, that there's actual science around them. So I think that was a very good way of introducing it, Thembi.
And Kanye, what do you think about the choice of examples that he used? He used water, he used oil, etc.
And sugar. Yeah, I think that was super.
Why do you think so?
Because he used, for example, he did, although they were not at times very good examples, like he said, water is a pure substance. And then he also said, okay, it has some dissolved substances, but they can relate to it, like he has said. Then the sugar, the oil, the mixed spice. I think it just he went all about to try and get all the things they could get from the kitchen, which was good.
And what do you think about the usage of language of words like disappear, words like dissolve, words like separated? The learners kept on talking about it disappeared, it separated. What do you think about those, Andrew?
Yes, I mean, one must be careful how one uses these words. But I think one must also avoid being too technical at times and actually simplifying things for learners, so that they can, as we've already said, the concept itself has got very interesting applications in industry, and as they go on with their studies, they're definitely going to encounter some scientific concepts which are based on their understanding of solutions. So I think the fact that he used some of those terms, separated and so on, although one must be careful not to use those terms too loosely, because then one introduces misconceptions. But I think on the whole that he was using language very well.
I also think it was important for him to use those simple words, because he was introducing heterogeneous and homogeneous, which you can best describe using disappear, or you can still see them.
So in a way, he started from the known to the unknown by using the words that learners are familiar with. What do you think the usage of the explanation of a solvent as a high quantity was used by the teacher?
Well, I think that's really good, because otherwise there's not really a way to distinguish between a solvent and a solute. I think what was also really good about the lesson was the way that he got learners to talk amongst themselves and to use the terminology themselves.
And what do you think about the way in which he has used models in the teaching of chemistry? Like learners were asked to make some sketches in order to represent some of those solutions.
Yes, again, very important for them to understand these things, and to enhance understanding. I think it's very powerful to use those kind of models. So learners can think about these things, can actually, I think that the models were not very noisy, and by that I mean that they didn't distract from what he actually wanted to achieve, and they didn't introduce any misconceptions. Very difficult for learners to conceptualize what actually happens in a solution, whether it's heterogeneous or homogeneous. And I think the model was a very good mental crutch, if you like, to assist them in comprehending what actually happens at the microscopic level.
And for me, what was good actually in those models, that learners actually had to draw those models, and yet in most cases I've seen them using some balls or things, actually designing such models. And then the other thing that I would like to find out is that the lesson as such had a lot of activities. The teacher started off by actually reviewing what they did during the previous lesson, and then later on he took them through the practical work, and then he had some worksheets. What do you think about the variety of activities in this particular lesson?
He started with the actual substances themselves, like putting the water and the oil, and then they would do it and see it physically, or separating. Or this is what you mean by suspension. So that by the time we came to giving them worksheets to say, let them do models, they could figure it out and write it because they've seen it. Whereas before you'd find that you demand too much of the learners. You tell them and then you draw sketches, but they don't have anything to see. And then you say they must come up with the models. So it was although it was a lot of things, it was necessary for them to eventually construct their own knowledge.
And
yes, if I could come in at that point, I think, again, the point must be made that the teacher was going from the concrete to the abstract, you know, and it was very well done, you know, in having those variety activities, the teacher ensured that learners are, the concept is actually properly developed according to the model of going from the concrete to the abstract. But I think we need also perhaps here to say that maybe this would be a fantastic opportunity for teachers to begin to explain to learners what models actually do, that they are merely models. That you know, none of us have actually seen atoms before, but there's a lot of evidence to substantiate the model of atoms, and that we can use that model, but you know, we can't stretch that model too far, and that models tend to change, but that models are only a way of helping us to explain what we see on a macro level.
Do you think the learners might have an idea that what they're seeing as a model is the real thing?
People may want to disagree with me, but this is my own personal criticism of models, that because teachers don't actually explain to the learners that these are merely models, that they might actually take that to be the absolute gospel truth, so to speak, you see. Whereas they're merely a tool to assist us to help understand what we see on a macro level.
What I liked about the teacher is that he was able to make them have models of solutions without having talked about atoms and compounds, you know. So they could eventually already see rather that there are different substances, therefore they should take on different shapes or different colors or different sizes. You know, so that was quite powerful for me.
And also in doing that, he didn't use the scientific words. He used the salt, the water, the oil, etc., which was very good.
In terms of equipment as well, the solutions that he chose were things that one could get from the supermarket. They weren't necessarily part of a chemical store.
And towards the end, he used a chalkboard a lot. What do you think about this, the using of the chalkboard? We always criticize the chalkboard, that teachers use the chalkboard a lot, they spend a lot of their time on the chalkboard.
For me, it sort of helped the learners and the teacher to summarize what they've been talking about, to identify the important points of the lesson, because usually what the teacher writes on the board is what is important. Before they will write everything and learners will just copy and then not be able to identify the key points. So this one is a good consolidating point for me.
So it was used as a good summary of what the learners were doing during the lesson. Is there any other thing that you think was important to capture from this lesson?
I was impressed maybe with the way he got the learners to discuss amongst themselves. And I think there was a very good element of peer teaching and peer learning, which is also very important, that learners should engage in these things and have discussions amongst themselves and come to some kind of consensus, you know. Also creates opportunity to create cognitive dissonance, you know, and then for the learners to compare their own conceptions with that with what the teacher then goes on to explain. And I think that was very good, that he engaged them in that way. Yes.
Okay, thank you, Andrew. Thank you, Kanye, and thank you, Liz. That's all we had for today. Thank you, viewers at home, and see you next time. Bye-bye.